Hello, welcome to the video notes for lesson 6-6, and this lesson is about using systems of equation to solve word problems, and in parentheses we have substitution. The first example we actually have here is dealing with a graph, and I just want to read through it and talk about it and come up with the equations for this, but we're not going to, I'll do the graph, but we're not going to spend too much time with this. The graphing piece anyways. I want you to be able to see how to do this using substitution. Alright, so the target for this lesson, I can use substitution to solve word problems. So in the past lessons we were given the equations. Now we are expected to write the equations. Alright, so I'm going to move the screen up a little bit so that we can see the whole word problem here. Okay, the Kulas are planning a party for New Year's. They wish to hire a DJ for 5 hours. They received 3 quotes. Which DJ would be the least expensive? So we're looking for the one that will cost the less. DJ Dave's service, or Dave's DJ service, sorry, $75 to set up cost for a setup cost plus $20 per hour. There's your rate. The minute you see that word per, you know you're looking at a rate. So let me underline that. That's our rate. By the way, they tell us right away what operation we're doing, we're adding. Molly's music DJ service, $50 setup cost plus $25 per hour. Again, there's our rate, $25 per hour. DJ Made Simple, $175. In other words, DJ Made Simple is just simply a flat fee. You pay $175 no matter how many hours it's for. No setup cost or anything. Alright, so we need to declare our variables. So we're going to let x equal number of hours. Now if you are someone that pays attention, you probably noticed that the hours is down on the x-axis here. So then obviously the y is going to be our total cost. Now for Dave's, this is going to be pretty simple. The total cost is $175. So y equals $175. Now, what does that mean? Well, that means we are dealing with a horizontal line right here. Oops, that's not a good horizontal line. Let's try again. At 175. So let's take a look at next one. Let's do, or I'm sorry, that wasn't Dave's, that was Simple. Sorry. Let me fix that. The Simple, DJ Made Simple, was a simple flat rate of $175. Now we're going to take a look at Dave's. Sorry if that confused any of you. You can bring that up in math and yell at me for it. Alright, so y equals, now it's $75 to set up plus, so $75 plus $20 per hour. Well, x is the number of hours, so it's 20x. So what does that look like? Well, at hour 0, it's $75. So let's think about what it's going to be at 5 hours, because that's what the Kulas are looking for. So if I plugged 5 in for x, 20 times 5 is 100. 100 plus 75 is 175. So there's my other point. So that's right here. So now I'm going to use my line tool. You would use your ruler and connect a nice straight line, putting an arrow going out. And I have one more. I have Molly's And for Molly's, we have y equals, this time the setup cost is $50 plus 25 per hour, 25x. So at hour 0, Molly gets $50. And then at 5 hours, so I plug in 5 for x, 5 times 25 is 125, plus 50 is 175. So I have my 2 points. I'll use my line tool to connect them. And this one looks like this. Okay, so you'll see that there's 3 different lines. But the interesting thing is, so the cool is they're looking for 5 hours. That's right here. All 3 of these services cost the same. So the answer to that question, all 3 will cost $175. So it doesn't matter who they go with. Maybe one of them's a friend, so they go with a friend. Alright? Now, the graphing was nice, but we'll be doing a lot more with substitution for this. And that's over on the next page, page 32. So, a broken furnace will cost $700 to repair. A new, more efficient furnace will cost $2,500. The present furnace, that's the broken one, averages about $1,000 per year for energy costs. And the new furnace would average about $700 per year. So the new one is more efficient. It costs less per year. The total cost, C, of repair or replacement, plus energy cost over n years can be represented by a system of equations. So our job is to write a system of equations to find how many years it would take for the total cost of repair to equal the total cost of replacement. Now, this is a word problem. So what does that mean? It means I'm going to use bucks. I'm going to put a box around the question. It's not really a question, it's actually, oops, that was a little sloppy. It's actually a statement or a task of what we're going to do. I am going to circle all the stuff for the broken one, and I'm going to underline all the information for the new one. And don't forget, they do also identify C and N for us. Alright, so I boxed the question, I underlined and circled. Doesn't appear as though there's any unimportant information. So the last thing I have is to solve with a smile. Okay, so let's talk about our variables really quick. We're letting C equal the cost, and that's what they tell us in the problem. And N represents the number of years. We have 2 situations here. We have our broken furnace, and we have our new furnace. So we're going to write 2 equations. The broken furnace is $700 to fix, plus $1,000 per year. There's our rate. The new furnace is $2,500, so it costs more for the new furnace. But it's $700 per year to run it. So because it's a new furnace, it runs better. Alright, so first step, we're going to write our equations, our systems of equations. Actually, you know what? Before I get to that, let's write down the equations for each of these. So this one is C, the cost is going to equal that $700 plus the $1,000 N per year. And the other one is $2,500 plus $700 per year. So, let's go to that first step now. So I'm going to write an equation. They're both equal to C. If I want to find out when their total cost is going to be the same, I'm going to set this equal to this. Then I only have one variable, it's N. So 700 plus 1,000 N equals 2,500 plus 700 N. Alright, steps for solving. Let's go ahead and subtract 700 N from both sides. Take care of that variable first. Draw your line or train tracks if you like. So I have 700 plus 1,000 minus 700 is 300 N equals 2,500. Now I'm going to just subtract the number 700 from both sides. And this zeroes out, and I have 300 N equals 1,800. Now I divide by 300. 1,800 or 1,800 divided by 300 is 6. So N is equal to 6. That's the number of years. Now really quick, let's figure out what the cost is. This is going to be step 2. So I want to find out what C is. I can pick either of these two equations to find that out. I'm going to be using my ESS here. So let's use that first equation. C equals 700 plus 1,000 N. So I substitute 6 in for N. Oops, that's supposed to be 1,000, not 100. 1,000 times 6. So C equals 700 plus 6,000. So C equals 6,700, and that's dollars, remember. So there is my other variable. So I now know what C and N are. C is the number of years, that's going to be 6 years. They are both going to equal the same amount, which is $6,700. Let's do one more step, step 3. We are going to do another ESS. We're going to do the check with the other equation just to make sure all our numbers work. Plus 700N. I know I'm getting right to the edge there. I hope you can fit it. So C is $6,700 equals 2,500 plus 700 times 6. Well, 700 times 6, I'm going to bring this down here. So I have 6,700 equals 2,500 plus 4,200. And yes, when you add those two together, you get 6,700. So does it check? Does it work? Yes, it does. Since I don't have any room to write my answer here, I'm going to write it above. So, writing a system of equations to find out how many years it would take for the total cost to equal. So it will take 6 years for the cost to be the same. Which is $6,700. Alright, so this video is getting kind of long. We need to wrap it up. Pause it if you need to copy any of this down, because I'm going to clear it in a second here. We are going to set up the next problem, but you are going to try it on your own. For every person that tries it, how about this? For every 2 people that try it, I'll give you a point on your scoreboard. And every 1 person that gets it right will get another additional point. So, wildlife biologists studied the weights of 2 alligators over a period of 12 months. The initial weight of the alligator, Alan, was 4 pounds, and its growth rate was 1.5 pounds per month. The initial weight of alligator Alice was 6 pounds, and her growth rate was 1 pound per month. write a system of equations the biologist could use to compare the weights of the alligators. At what point will the alligators be the same weight? So, this is another box problem. Put a box around the question. You are going to answer that question, but you're also going to be writing a system of equations. Alright? Now, I am going to circle the stuff for alligator Alan. There's his rate and the weight, the initial weight. I'm going to underline the stuff for alligator Alice, 1 pound per year. And let's write that stuff down. So Alan has initial weight of 4 pounds and a rate of 1.5, so that's 4 pounds. 1.5 pounds per month. I'll abbreviate month. So you're going to write an equation for alligator Alan in a second. Alligator Alice is 6 pounds initial weight, and the rate for Alice is 1 pound per month. Now, what are our variables? We're going to let X equal number of months, and Y is going to be the number of pounds or the total weight. So, I'm going to get you set up and then we're going to stop here. So you need to write an equation for Alan and for Alice. Then you are going to set up a system and solve it. You're going to find the other variable, so you're going to find X and then find Y. Then you're going to check it, and then don't forget to answer the question at the end. Remember, everybody, that for every 2 that try it, you get a point. For every person that gets it right, you'll get another point. All right, good luck, and we will see you in math.